Hi folks, Will from MinIO here, and in this video we're going to give you a brief introduction to MinIO, including some of the core concepts around object storage and also the different ways that you can actually deploy MinIO. So let's go ahead and start off with some of the core concepts, starting off with what is an object. Now, those of you who already know what an object are, maybe you want to fast forward through this video or jump into the next one, all good choices. But an object is basically a binary large object or blob. You can think of the contents of your local computer. You can think of documents, images, videos, all that other fun stuff. Blobs can have any size, any format. They're not restricted in any way. They do not depend on a specific hierarchy in the file system or any kind of access or availability requirements. They have rich metadata, which you can use to provide additional context around your object as you have saved it. So you don't have to put everything in the file itself. You don't have to put everything in the file name. You have all this metadata that you can use. You can store it anywhere in the system. It's just a blob. You already interact with objects basically all the time when you're working with your computer, any kind of document, any photos, videos, music, anything like that. Any data that you get from an AI system or from machine learning pipelines. If you're streaming video or you're working with time series data from metrics or Internet of Things devices, any sensors that you're using, these are all sending you data, which you can look at and think of as an object, right? Even if I'm doing a big backup, like I'm zipping up all of my files on my file system and putting them in the cloud, that is just going to be an object, right? So all of that stuff is objects. Everything you interact with on your computer is objects. You can think of it that way. The other thing that we use with MinIO, with object storage, is this concept of a bucket. A bucket is going to be a collection of related objects that all share the same policies. They all have the same sort of configurations. You can think of a bucket like a volume on your local operating system. Amazon generally limits buckets to about 100 per account. When you're using Amazon S3, this also allows you to have each bucket with a globally unique DNS that makes accessing your different buckets very, very simple. MinIO, on the other hand, does not have bucket limits. You can set up as many buckets as you want, but you should still sort of think of them like volumes. Now, if you're going to be a developer, if you're going to be a client to MinIO, you're probably not going to be creating the buckets, just like your application on your local file system is not creating a volume. Your application is going to consume it. So you're going to have an object storage administrator who's going to be creating the buckets for the apps to use, and the applications are going to interact with those buckets using HTTP, put, get, all that other fun stuff. There's really no constraint on the hierarchy of the storage or access inside a particular bucket. That's where we get into things like prefixes. We'll talk more about that a little later on. So object storage itself is something that's designed to have these flexible namespaces, which you can think of as your buckets, which store data in any arbitrary hierarchy from very flat, which would be no prefixes. You've got all of your objects just in your bucket, or deeply nested, where you might have a bucket named videos, and then you would have a prefix named cats, and then you'd have a prefix under that named funny, and then you'd have a prefix under that named musical, and then way down at the bottom, you'd have your video of piano cat. Anyway, the point is that you can have no prefixes or you can have many prefixes. As far as the object storage is concerned, it's just a way to find the object that you're looking for. The object itself consists of a unique ID. Generally speaking, it's the name of the object that's the unique ID. And then we have the data and also their full metadata, and that's all stored in the blob. So there's no reliance on any external applications or any middleware or anything to determine what an object is. You can store all that information with the object. You can have multiple storage pools, so you can actually have scaling of your object storage from terabytes up to exabytes. You can have a huge amount of storage available, and this is all accessible via an HTTP-based RESTful API. And what that means is that if your application can speak basic HTTP, and basically I can't think of a programming language that doesn't, you can access your object storage. Using this cloud-native design allows your deployment to any infrastructure using either bare metal locally or orchestrated management methods if you're using Kubernetes or you're using something like Red Hat, OpenShift, or all that other fun stuff. You can actually deploy your MinIO object storage very, very easily. So the big question is, what does it mean to be S3 compatible object storage? Well, AWS S3 is the big player in the object storage space, has been for a very long time. They have this one API for any S3 compatible service. That means that you can have portability of your application across services so long as they're S3 compatible. And this also means that you can have multi-cloud deployments. Now, the thing is that not all object storage services are S3 compatible, and some only have partial compatibility, blah, 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 blah. So the thing is, S3 is not open source, and it requires a lot of testing and reverse engineering to make sure that you are compatible with it. So the question becomes, why is S3 compatibility important if it's not open source? Well, the big thing about S3 is that it is a very, very common integration. Many software providers these days include S3 compatibility as part of their storage. So if you're using Spark or Starburst, Kafka, you're using TensorFlow, all of these different things will have these S3 calls so that they can access their data, right? So this allows deploying an S3 compatible object store as a central resource for a whole ecosystem of applications. You can separate these all out by buckets. You can even separate them out by prefix if you need them to access the same bucket, right? The data your custom application is going to access is likely to be in S3 already, or it soon will. So if I'm writing a custom application that's going to be data-centric, eventually you're going to start thinking about scaling up to the size of many, many terabytes, which means S3, which means cloud. So this brings us to the question, if I can just use S3, why would I use MinIO object storage? The benefit of MinIO is that it scales up very, very easily. It gives you S3 compatibility everywhere. So Amazon S3 API, that's the de facto standard for object storage. MinIO is implementing the Amazon S3 v2, v4 API, right? We've done this through reverse engineering. We've done this through extensive testing. The nice thing about MinIO is that you can start very simple and then grow more complex. You can deploy as a local Docker container for a proof of concept. If I'm just writing my application, I want to make sure that it's something that somebody wants to actually invest in. I don't have to spend a lot of my resources getting all this AWS S3 set up. I can just deploy a little Docker engine with a little drive attached to it, and I can run my S3 compatible object storage right there. That will allow me to then later shift to a local cluster, so I can do an on-prem if the data is very sensitive, or I can even go to cloud. I can even go to different clouds. Many cloud providers now support MinIO. This also gives us very powerful data integrity. That's what MinIO has got built in. Our data protection features, it's erasure code. It means you can lose up to half of your drives and still recover from it. Not even just recover from it. You can lose half of your drives and still be functional, right? You can still serve data depending on your setup. We also have this server-side data replication. You have active replication available, as well as active passive replication. That means that you can have automated application failover between sites. So if I have two sites running with the same data, I can have them mirror each other. If site 1 goes down, site 2 remains running, my application can simply fail over to that other site and all the data will be there. I don't even need to do anything like change the prefix names. I can have the same prefix name on both sides. We are also 100% designed to be secure from the start. We integrate with different identity providers. Anybody that has OpenID or LDAP available, you can integrate with them very, very easily. And we also have encryption available, encryption on disk. So what does a simple MinIO deployment topology look like? Well, your applications are going to interact with a load balancer to route the requests to your MinIO host through the S3 API layer. Each MinIO server in your cluster has a complete picture of the distributed topology, so the application can connect to any node in the deployment, which means your load balancer doesn't have to be that smart. It just needs to know where all the servers are because each server in the cluster can answer the question. What this means to you is that your application can start with a very, very simple MinIO deployment and then grow very easily as you go. And so that's everything that you need to know about object storage and also how MinIO implements the S3 API. I hope you've enjoyed this video. If you'd like to chat with us, you can use any of the methods you see here on the screen. You can also Slack us on slack.min.io or just leave a comment here on the video. We'll see you for the next one.